A local bakery has determined a probability distribution for the number of cheesecakes that they sell in a given day. Part A. What is the probability of selling 15 cheesecakes in a single day? Well, that unfortunately is the one probability that's missing in the table. If this was asking for 10 cheesecakes, then the answer would be 0.09. We just list the probability associated with that particular outcome. However, we can figure out what this missing probability is because in a probability distribution, the sum of all the probabilities must be equal to 1. So what that means is if I take all the probabilities in that column, add them together, but taking into account that the missing probability we don't know the value of, so I could just put an X in for that. All of those would have to add up to 1. So that means 0.22 plus 0.37 plus 0.09 plus another 0.09 adds up to 0.77 plus our missing probability is equal to 1. Now this is just a simple linear equation which we can solve for x by getting it by itself. And the way we do that is subtract 0.77 from both sides. So x equals 1 minus the sum of the probabilities we have so far, which is 0.23. So that missing probability is 0.23. Okay, what is the probability of selling at least 10 cheesecakes? So at least 10 cheesecakes would be 10 or more. So the number of cheesecakes that we sell is greater than or equal to 10. So that group, 10, 15, and 20, qualifies, which means I would add together all of their respective probabilities. So that would be 0.09 plus 0.23 plus 0.09, and let's find out what that is. 0.41. What is the probability of selling 5 or 15 cheesecakes? So the probability of selling 5 or 15 cheesecakes, OR tells you to add probabilities. So if we have 5 or 15, we would add together 0.37 and 0.23 to get our probability. There wouldn't be any overlap because all of these probabilities in the distribution are disjoint from one another. They're mutually exclusive. So we would just take the probability that 5 cheesecakes are sold plus the probability that 15 cheesecakes are sold. 0.37 plus 0.23, which is 0.6. What is the probability? Oh boy, a couple of misspellings there. What is the probability of selling 25 cheesecakes? Well, there is no data values where 25 cheesecakes were sold. So that's not part of our distribution. So the only thing that we could say is the probability of selling 25 cheesecakes would be 0 given the current information. It's not necessarily that it's impossible that that would happen. It's just that it hasn't happened yet in the empirical probability. So, what is the probability of selling at most 10 cheesecakes? So at most 10 cheesecakes would be 0, 5, or 10. Because at most 10 would be less than 10, but including 10. And sometimes you have to parse through the English language in order to understand those concepts. But at most 10 would be up to and including. So we would add together 0.22 plus 0.37 plus 0.09 for a total of 0.68 for our probability. What is the expected number of cheesecakes sold in a day? So the expected number of cheesecakes sold in a day is equal to the mean of the distribution. So effectively, what this is asking us to do is to find the mean of this probability distribution. So I would need to put, since this is grouped data, the value of our random variable into L1 and each associated probability in L2. Then I would use one_var_stats, which can help me find a weighted mean, which is what we need for grouped data, taking care to make sure I enter L1, L2, so that the mean of this distribution is 8. And that would be the expected value.